AB Calculus, Note Card 18, Quotient Rule. This is the 18th in the series of lessons inspired by Stacy McMullen, formerly of the Dallas Independent School District. And here we go. The quotient rule, the derivative of the quotient of two differentiable functions, and these functions defined here as u divided by v, where v is not equal to 0, is vu prime minus uv prime over v squared. Another device for remembering the quotient rule is d dx of high over ho equals ho d high minus high d ho over ho squared. There's another one yet that I was taught by one of Stacy's mentees and collaborators, Tracy Etheridge, which was in the form of song. The song goes like this: Lodi, 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 high, minus hidey, hidey, low, all over low squared. So that would be like the one above, kind of like, but d dx of high over low is lodi, 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 high, lodi high, minus hidey, hidey, low, all over low squared. So you have low squared. And there's yet another way of looking at this. If you have this u over v, let's try this again. d dx of u over v, you can write this as u times v to the negative 1 power, and treat this like a product rule, this product of u and v to the negative 1 power, and you end up with, you'll end up still here. So different ways of doing these things. Okay, let's get to the problems. One, if v of t equals t squared over 3t squared minus 2t plus 1, find v prime of t. And so for this, I'm going to organize the numerator as high and the denominator as low. And so to the right, up here, I'm going to say high is equal to t squared, and d high is equal to 2t, and low is equal to 3t squared minus 2t plus 1, and d low is equal to 6t minus 2. And so we can go with this. So v prime of t is going to be equal to low, and low is 3t squared minus 2t plus 1. D high, and d high is 2t. T minus high d low, and high is t squared, and d low is 6t minus 2 all over low, all over low squared. I could sing it better in the morning sometimes when I'm a little hoarse. So really now, at this point forward, it's a matter of distribution of the terms. Okay, so v prime of t is equal to 2t times 3t squared, 2t times negative 2t, and 2t times 1. So we're going to have 6t cubed. In these distributions, it is really easy to get a sign error. And then we have 2t times negative 2t, so we have minus 4t squared. And then we have plus 2t. And then we have the distribution of t squared, over here. So we have minus t squared times 6t, so it's going to be minus 6t cubed, and then minus t squared times negative 2, so it'll be plus 2t squared all over rho squared. So yeah, this is just the cleanup process here. So we have 6t cubed minus 6t cubed, and so we have negative 6t squared plus 2t squared. That's going to be negative 2t squared, and plus 2t all over rho squared. So that will be our answer simplified. Okay, next problem. What is the instantaneous rate of change at x equals 2 of the function f given by f of x equals x squared minus 2 over x minus 1? Same method of organizing as the last problem. So we'll have high is going to be our numerator here. Low is going to be our numerator, our denominator down here. So at the right, we say high is equal to x squared minus 2. D high is equal to 2x. Low is equal to x minus 1. And d low, the derivative of x minus 1, is 1. So f prime of x is equal to low, with this x minus 1, d high, which is 2x, minus high, and high is x squared minus 2, d low, which is 1, all over rho squared. So we have 20x minus 1 squared. And then we can simplify f prime of x is equal to 2x times x, which is 2x squared, minus 2x, and then we have minus x squared, and then minus negative 2, so we'll call that plus 2, all over 20x minus 1 squared. And now simplifying, we have 2x squared minus x squared. That's going to simplify to simply x squared minus 2x plus 2 over quantity x minus 1 squared, and it's f prime of x. Now we're going to, at x equals 2, we will have that be listed as f prime of 2, which is going to be in the numerator 2 squared minus 2 times 2 plus 2. In the denominator we have 2 minus 1 squared. Well, in this case, 2 squared minus 2 times 2. So we have 2 over 2, calling 2 minus 1 squared from 1. So our answer is going to be 1. Or, let me take that back. 2. There we are. That's better. Okay, there we go. Let's go on to the next problem. Find ds dt for s of t equals 6t squared over 5 plus 2 over cube root of t squared. And so we can say, we can rewrite ds dt as s prime of t. Okay? But first, what I'm going to do is put s of t in a more, what I call calculus-friendly form. So I'm going to have first 6/5 of t squared, and then this plus 2, and then this cube root of t squared in the bottom is going to be t to the power of 2/3 when we bring this up into the numerator. So a calculus-friendly form. So now we're going to take the derivative of 6/5 t squared, which is going to be 2 times 6/5, and then we'll have t to the 2 minus 1, and it's just going to be t plus 2/3 times 2 t to the 2/3 minus 1 is going to be t to the negative 1/3. And then further simplifying, here we have, put s prime of t equals 12/5 t, and then 2 times 2 will equal 4. So we have 4 over 3, and this t to the negative 1/3 power comes down here as cube root of t. Now, did you see anything in here that looked like a quotient rule application? I did not. So this is an example of a problem that Stacy put in there to remind us that, hey, we have to, when we do these things, still think about what we're doing. And then we don't have really a quotient of two functions. Next, let's go to problem 4. Suppose that f of 5 equals 1, f prime of 5 equals 6, g of 5 equals negative 3, g prime of 5 equals 2. Find the quotient of g and f, or g over f prime of 5. And so what we're going to have is g, we're going to define to be in the numerator here as the high, and f in the denominator we'll call the low. And so we're going to just organize this and be able to solve this pretty quickly. So our high is going to be g of 5, and g of 5 is going to be equal to negative 3, and d high, our derivative of the high, is going to be g prime of 5. And where do we see that? Here, g prime of 5 equals 2. Our low, f of 5, there it is, f of 5 equals 1, and d low is equal to f prime of 5. And where do we see that? Right here, f prime of 5 equals 6. Then you can kind of double check to make sure you have things right. So we have g over f prime of 5 is going to be equal to low, which is 1, d high, which is 2, minus high, which is negative 3, d low, which is 6, all over low squared. And so g over f prime, I have it outside the parentheses here, like this. There we go. G prime, g over f prime of 5 is going to be equal to 2 minus negative, okay, it's going to be 18. So it's going to be 2 plus 18 over 1, which is going to be equal to 20. So that's going to be G over F prime of 5 is equal to 20. Next, I think it's our last problem in this set. Find the slope of the line tangent to y equals 3 sine x over 4 plus cosine x at x equals negative pi over 2. So a trigonometric application here. So we're going to continue to be consistent. This will be in the numerator our high. The denominator, we will call this our low. So I'm going to write this over to the left. Okay, high is equal to 3 sine x, and d high is going to be the derivative of high, which is going to be equal to 3 times the derivative of sine x, which is cosine x, and low is equal to 4 plus cosine x, and d low is equal to the derivative of the low. Well, the derivative of 4 is 0. The derivative of cosine x is minus or negative sine x. And so y prime, working below here, is equal to low 4 plus cosine x, d high, which is 3 cosine x, minus high, and high is 3 sine x, d low, which is negative sine x. And it's going to be all over low squared, which is going to be 24 plus cosine x squared. So, gosh, we have distribution here. We have 4 times 3 cosine x is going to be 12 cosine squared x. And then we have, oops, that's not right. We have 12 cosine x is what it is. And then you'll have 3 times, plus 3 times cosine squared x. And then we're going to have negative 3 times negative sine x. That's going to end up being plus 3 sine squared x. And it's going to be over 4 plus cosine x squared. So there's some similarities here. Yeah, there are. I'm just going to keep working below. 12 cosine x and we have plus 3 times cosine squared x plus sine squared x over quantity 4 plus cosine x squared. Okay, that's y prime, y prime. Now, this cosine squared x plus sine squared x, I hope you may remember from your pre-calculus days that that's going to be the Pythagorean identity. So this cosine squared x plus sine squared x is going to be 1. So in the numerator, we're going to have 12 cosine x plus 3 times 1. In the denominator, we're going to bring down this 4 plus cosine x squared. And then at x equals negative pi over 2, so we have y prime of negative pi over 2. Well, negative pi over 2, for reference sake, is going to occur if we have a unit circle of trigonometry. Negative pi over 2 is going to be this thing right here on the unit circle. So that's going to be the x value for that. Okay, that's going to be our sine cosine is going to be cosine is 0, sine is negative 1. So anywhere we see cosine is going to be 0. So that's going to be equal to 12 times 0 plus 3 over this denominator 4 plus 0 squared. And so what we have is 3 over 4 squared, or 3/16. So that's going to be our slope, or m sub t. So a lot of these trigonometric problems are worked out like this, where a lot of stuff just cancels out as 0. So try not to get intimidated whenever you see trigonometry in your tests. Good luck, and thanks for viewing.